Signal Sciences secures the most important web applications, APIs, and microservices of the world's leading companies, protecting over 7,500 applications and 150 billion production requests per week. Signal Sciences Next-Gen WAF and RASP help companies increase security and maintain site reliability without sacrificing velocity, all at the lowest total cost of ownership. Signal Sciences patented technology protects any application against any attack with integrations into any DevOps toolchain. Signal Sciences. Demand more from your WAF. Learn more at securityweekly.com/Signal Sciences. As the world of software-driven everything becomes a reality and development cycles speed up, sales teams are taking a new approach to application security, one that enables security teams to scale by empowering developers to integrate security into their development workflows and toolsets, all while giving security teams the visibility and control they need. Snyk helps software-driven businesses develop fast and stay secure with a developer-first solution that seamlessly and proactively finds and fixes vulnerabilities in open-source libraries and containers. Learn more and see the solution for yourself at securityweekly.com/Snyk. Make sure your team is prepared to fight off the latest cybersecurity threat. IT Pro TV is the resource to keep you and your IT team skills up to date. You can stream IT Pro TV courses live and on demand, so there's no need to send staff to off-site training. Team subscriptions include Pro Portal, so managers have full control over your team's training schedule. Go to itpro.tv/ASW and use the code ASW30 to try it free for 7 days and receive 30% off your monthly membership.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by Matt Alderman and John Kinsella. Please join Ocean and Security Weekly at Salve Regina University Pell Center on Wednesday, March 18th, 2020 from 9 a.m. to 3 p.m. for Ocean's Cybersecurity Exchange Day. Visit securityweekly.com/Ocean2020 to register for free. Matt, well, you had a week off from the news, and John and I went through a whole bunch of bugs last week, and this week we're going to dive into a somewhat different nature of bugs. Some researchers out of Singapore University took a look at Bluetooth Low Energy, the protocol, and some of the devices that have implemented the design for it, and they came out with a good round number of 10 different vulnerabilities that they found in that, to varying degrees of impact.
Yeah, we actually covered this on Paul Security Weekly. I was not on vacation last week. I was at the Social Security Administration office, which is why I said you guys had a lot more fun than I did. And then I went to studio. So we covered part of this actually on Thursday night, which is interesting because, you know, Larry Pesce has a lot of experience here with some of the Bluetooth devices. And what I found interesting out of some of these vulnerabilities is this report goes into some of the impact on medical devices and some of the consumer products, but our keyboards, our mice on the computers use low energy as well. You know, could you do things like keyloggers using some of these vulnerabilities, right? So I think there's more impact potentially than just, you know, a deadlock or a crash on some of these medical devices, which, hey, from a safety perspective would just freak me out. But there's also an opportunity for some security bypass where if you could break the encryption on these low energy devices, you could also turn some of these devices into keyloggers and some other interesting ways to get data.
Yeah, I think for me, there are a couple angles that stood out for me that I thought might be interesting from an application security perspective here. And to riff off of what you were just saying too, there's also things to consider that this isn't necessarily an attack at scale in the sense that it's easy to go out and scan and exploit all these, because a lot of the attacks here in the paper are described as you have to be within radio range. Now, if you have a fancy Yagi antenna or a high gain antenna, radio range might be actually more than just a few meters, but that does mean that the potential impact at scale to hit large populations of devices or users behind those devices isn't necessarily there until or unless these are devices that are in large crowds, airports, hotels, conferences like RSA coming up, or concerts was the word I was trying to get out. So there are going to be potentially interesting attack models, not necessarily because of these flaws directly, but that was on my mind from what you were just describing. But the other thing that stood out for me was it was really neat to see this as an analysis of a protocol. Because we actually haven't seen that many new protocols for one thing. We have Quick or Speedy or that what's been coming out, the companies like Google and Cloudflare have been working on. But what was neat here is that even the paper was describing it's not really easy to instrument and be testing a lot of the protocol layers here to do these types of attacks. And what they were really saying was, are there logic flaws or are there feature or workflow flaws within these protocols that we can pick apart? And is there an implementation in that flaw that was saying the design maybe was good, but the implementation was slightly off? And that goes in that same thing when we look at crypto stacks. The math behind some of the crypto may be good, but the implementation can easily go sideways and be exploited.
It's one of the problems when you pull that crypto out from the underlying protocol itself and say, oh, it's the application's job to do the authentication and identification of this. So you're now suddenly going from something being part of that core protocol, which it's there to a degree, but at least from what I've seen, a lot of it is expected to be done by the vendor who's packaging that device with the protocol.
Yeah, that's interesting. So we have now a couple things. So one, me kind of advocating application security needs to include that business logic, that workflow logic, or in protocol analysis in this sense. And that what you are also saying too, John, is at what point where do you place your security boundary? Do you want to do that and say, we're going to use TCP and UDP, no problem, but all of our websites are TLS anyway. So, in the modern age of open Wi-Fi, not using a VPN honestly isn't necessarily that bad if every site is going to be HTTPS. And in fact, your browsers and your devices are actually going to silently promote HTTP to HTTPS. It does mean that you're going to be exposed to other types of wireless and Wi-Fi attacks. Maybe they're just griefing and trying to disassociate you from networks. In a lot of cases, this paper was pointing out what are essentially denial of service or causing you to reboot your device. But of course, if we just say the device has to be rebooted, when that's a medical device or it's a device that's carrying, has more of a safety component to it, suddenly that becomes a little bit more interesting.
Yeah, and you also have to make sure you're not allowing TLS 1.0 or 1.1, because if you allow those downgrades and now you have browser support being dropped for them, it's a little more complex than just, let the application or whatever use just standard library, because we see version differences and other things that could also create some havoc.
I think people would be a little shocked by how much Bluetooth LE is out there. At least for me, I'm sort of used to, I have a pretty good sense of what, how many Wi-Fi networks are around me, in your Mac or PC or whatever you've got. When you click on a laptop, at least when you click in your, trying to figure out what Wi-Fi you should hop on, you'll see a list of what else is out there. But pretty seldom do we actually do that we might do it for Bluetooth, but almost never for Bluetooth LE. I was playing around a month ago with I think HCI scan on playing with IoT stuff. And we scan and this list of stuff comes back and it looks like it's never ending, especially if you're in a city or something. Back to your point, Mike, I think it's sort of crazy. And for folks out there who want to play with that, it's a really great use for a Raspberry Pi. It's sometimes hard on the Mac, either if you get the software on a Mac or especially if you try to get a Linux virtual machine on here, actually getting complete control of your Bluetooth device on the Mac to be able to start scanning or doing manipulation. A lot easier to just get a Raspberry and do it on there, but people would be a little surprised how much of it's out there, I think.
Yeah, so for the hobbyists out there want to jump into some software-defined radio and new radio, that could be some pretty fun stuff to dive into as well. I do want to, before I forget, take Matt's comment and use that to a great segue, jumping down to one of our other articles about just what Matt said. TLS 1.0 and 1.1 are in fact going away in practice, if not in even though they won't be erased from existence quite yet, because the link here is from Mozilla saying now that or giving heads up that support for this is dropping in March. So here's a friendly reminder that Firefox 74 is TLS 1.2 as a minimum, and this is actually the other browsers are going to follow suit with this. But one of the things I wanted to pull out here was, and we can actually tie this also to Bluetooth LE and the problems that were the certification problems that the paper was calling out, or the need for firmware updates, is that if you look at Beast, Crime, and Poodle, which are the TLS flaws that were mentioned explicitly in the Mozilla article, those are from 2011, 2012, 2014. So it's taken the ecosystem anywhere from, depending on how you want to do your calendar math, 6 to 8 years to migrate off of a known bad problem. And even this is something that when we were talking with Doug was talking about do the basics, patching. Yeah. Clearly, patching can be a lot more complicated when you're talking at scale of not millions, but hundreds of millions, if not a few billion browsers, supporting one of these TLS versions.
Yeah, and the applications that are allowing the support for the older versions. I mean, there's a lot of dependencies here that have to be addressed, and it's taken us this long to the point. I mean, PCI made this announcement, this has been out there for a while, but now the browsers are finally deprecating the support out of their browsers 6 to 8 years later. It takes a long time to get this stuff out.
And that's why I want to... Yeah, go ahead, John.
Sorry, it reminds me a little bit of IPv6. We've been talking about that for forever and ever and ever, and that's finally starting to hit. But I mean, you have this TLS, 1.0 and 1.1. It's come on, it's about time.
Yeah, and it's sort of that. It's about time. I wanted to throw that out as sort of that here's the homework for the week for listeners. You can either use it with TLS 1.0 and 1.1 to say what in your environment still supports it, and ask the hard question, why haven't you gotten rid of it yet? Or what does it take to do so? But you can also generalize that and say, what internal services do you have that represent tech debt? Everyone knows, I'm sure, they work at some organization that has this one service and no one owns it. No one wants to touch the repo because it's brittle. The team that worked on it has been long gone. And everyone knows that, we should stop using that. We should do something else. But 6 months later, a year later, 2 years later, maybe you're still relying on that service. So that's one of those exercises to say, as a security challenge, what can you do actually to go in and actually have better migration paths and tamp down tech debt? So rather than 6 to 8 years, you're dealing with 6 to 8 months in your environment. And I think take that and talking about tech debt and building policies and procedures and process perhaps was backed by some automation. But I think I'll use that to jump us over to the OWASP Software Assurance Maturity Model. That version 2 was just released. I missed this at the end of January, but didn't want to do a disservice of ignoring it and wanted to give it the service of highlighting it, because I think there's some interesting things here in the software assurance maturity. And one of the things I just wanted to focus on is looking at, they have 5 different business functions that they call out. One in particular is design. And in the design, I like to point out the difference between a lot of what we talk about in terms of automation and tooling and build versus buy from the workflow and the logic that we see inside what we were just talking about with Bluetooth. So for example, going through security requirements, there's what are the software requirements of what you're actually building, not particularly what the tech stack is, because under security requirements, it does call out an angle of supplier security, but also says, what are you just trying to build and what could go wrong? Same with building something like your architecture design. What's the design of your Bluetooth LE model, and is that protocol pretty solid or not? Rather than what are the particular chipsets, how are those chipsets protected from anti-tampering, how are you building the software for that firmware in a good CI/CD process, or building supply chain. All these are important, but my long-winded way of saying there's a lot of complexity here, and I think the way that this breaks down a way of thinking can be pretty helpful for organizations.
Yeah, what I thought was interesting, they put a whole new section in here around implementation, right? We talk a lot about securing the CI/CD pipeline. Well, the CI of that is this concept of continuous integration and then deployment, right? And when you look at some of the things they've identified here around secure build, secure deployment, defect management, These are all integral parts of that CI/CD pipeline, and this is where I think a lot of security tools can get implemented effectively to help secure the components across that build pipeline, but they have to be done in the right way. So this whole new section, I think, was great to really help people start to identify what are those components in what we call the traditional CI/CD pipeline that we have to think about.
Yeah, that's a great call out, because rather than just go from design to verifying the design, paying attention to how that design was implemented and say, did that actually match what was intended? And that's how we get those crypto problems, the Bluetooth problems. And I think
dependency issues and all the other things we talked about in the last segment, right? All those challenges that we think about in the build process.
Yes. And go ahead.
Pretty nice in here also the Quickstart guide, right? So a lot of these OWASP documents, they start off being really heavy, and it's like, oh my God, I have to sit down and cut out the next 5 hours of my day to try and read through this document. Some of them now they've started doing like either well, they've done cheat sheets for years, but on this one they've got a quick start document to sort of get people up to speed a little quicker and give them a taste of what's coming. So I think that's pretty nice for folks to sort of dip a toe into the water.
Absolutely, and there's a great chart that's showing like the stream A, stream B, two streams for each of the major functions that we're referring to. So it's a great visual presentation to help you mentally get approach the problem. And there's also a crossing the stream joke in there. Yeah, exactly. I was basically going to beat you to it, and then we both killed it. So let's pretend that never happened and move on to understanding trusted execution environments. This one I wanted to highlight because in the spirit of Bluetooth LE, that's something that is a hardware stack or hardware environment that perhaps not as many security practitioners are as familiar with. So there's good reading just to learn about something new, learn about some protocols. Here is the TrustZone on ARM and ARM devices, commonly, for example, that you'll find in a lot of Android phones. So you may be an Android hacker, focusing at the app layer, but this is a great deep dive from Azaria Labs, which we've mentioned in the past, who produces really high quality content. They're very approachable, very well written to understanding basic components, specifically around ARM and ARM architectures, both of what they are as well as how to take them apart. Because once you understand something really well, you can start to understand and guess at, here's an assumption into the design, or here's something in the design that was not really called out well. And that's a thought process that you'll actually see demonstrated in that Bluetooth paper as well. So thought I'd highlight this. Definitely not easy reading, so it may take you more than 5 or 10 minutes to get through, but I promise you it's worth it.
Yeah, I thought it was actually really great, because I think for a lot of folks out there, if you want to start playing with getting your hands into, well, AF mobile in general, right? It's a lot easier to get dirty on an Android device than an iOS device. But then also for folks who just want to try and get into what is this trusted compute thing that we keep talking about, right? If you actually want to start poking and prodding, not the easiest to do in a cloud environment. You can probably do it on a laptop, but if you have, like, again, a cheap Android phone with one of these ARM chips on there, can poke and prod and hack and do what you want to your heart's extent and get a sense for it. Yeah, it looks like it's going to be a really great blog series. I at least only saw the first one. I don't know if they have more pieces done yet, but it looks like a pretty good read to me.
Yeah, there's just a lot of TLAs in here, so you really got to get your arms around all the definitions of all the different components to really start to understand it. Pretty
well
technical.
Played with getting your arms around this architecture there, Matt. I appreciate that.
My trusted arms.
Yes. Well, let's turn those trusted arms to how they can wrap around Chrome extensions. And here's another reason. Here's something else that we've actually talked about in the past. So the CRXcavator is a tool from Duo Labs, and they're basically saying, we know that browsers, and Google Chrome in particular, loves to have lots of extensions. And with those extensions comes all sorts of security problems, partially because of the design of what extensions can do, meaning they could read the entire DOM for all origins, which essentially consider that a universal cross-site scripting, for example. Or even if they can read the DOM within some restrictions restricted origins, that doesn't mean that, or that doesn't preclude a malicious extension from siphoning off data with that shows up in that DOM, whether it's credentials or other type of sensitive data or just email messages for that matter. So what I wanted to highlight here is, with that preamble aside, is that CRXcavator tool is one of those it's a openly available tool that you could build into your third-party dependency program. For example, it's one of those things, for example, if you're working like Doug in an organization, and that's another thing to add to your tool chest, as well as it does rely on RetireJS. So here's one of the open source components of it that is a way just to review legacy or other types of JavaScript libraries, JavaScript components that should be, as the name implies, retired. So some other things that you can, if you don't want to take the CRXcavator directly because you're not dealing with extensions, you can take the RetireJS and just drop it into your environment and see what happens in terms of all the legacy code that you might be dealing with.
Yeah, what I thought was interesting, because you've got a link to the tool, so you can go in and you can search for different plugins that you use. So HubSpot, good. But the application launcher for Drive is a little risky, just so everybody knows, a little higher than I thought. Because most of the ones that show up on their top reports, I'm like, yeah, I don't use any of those plugins. But it's interesting when you start plugging in the extensions you're actually using.
And the other thing I liked about this too is that CRXcavator, they do of course roll up to a number because everybody wants a number, or they want the happy face or sad face, like, should I use this extension or not use this? But what they do is they pull down a couple of information about an extension into several categories. So they talk about content security policy, meaning how much access is it actually getting to the DOM or across DOMs, or across origins, or just what can it see inside your browser. The other thing is also permissions, about what can it do with that access in your browser. The RetireJS is that aspect of just what other JavaScript libraries is it pulling in, meaning is it relying on something with known vulnerabilities? And then also another category of the web store details. Basically, what is the rough reputation, or at a glance, the reputational aspects of who created this extension. And those are some interesting ways that you could take those types of concepts and perhaps apply them in other ways as you think about risk within your organization or with other things that your organization is using. And rather just, you can come up with a number, but have some reasons or some ways of reasoning to that number. And I think those categories like CSP and permissions and RetireJS, those three are pretty informative right there, and can lead someone to make different risk calculations and say, I don't really care if I'll install something if it's a 6.3, where someone else may say, I won't install anything that's lower than a 11, something like that.
Yeah, I hadn't looked at specifically RetireJS for a while. I can't remember last time I looked at it, but I've never actually put it into a CI pipeline. I think last time I looked at it, it was still fairly young. Just glancing over it now, what the first thing caught my eye, the Grunts plugin. So for folks that are doing, automated builds of a JavaScript, either for your single page app or something server side, if you can just go ahead and drop this plugin in there and automatically be notified as part of your CI process, guys, it's free. That seems like a no-brainer for me on that side of things, not just the browser side.
Yeah, so it's also like look at the tools that other people have created, and look at what they're doing, and beg, borrow, and steal. And when it's open source, that becomes a little bit easier. Adopt what they've done and see how that fits within your environment. And that, I think, can even tie into that build versus buy discussion we were having with Doug, because you could say that RetireJS, maybe you don't want to actually. It's not going to work at scale. It's not going to be as robust, or it's not going to be as updated. But if you need to get buy-in from, hopefully you don't need to get buy-in from your CISO, but if you need to get buy-in from the engineering teams or the team that's responsible for CI/CD about why how pervasive this problem may be. Doing a proof of concept with something like RetireJS can be a great stepping stone into demonstrating and putting visibility onto a problem, rather than just saying, yeah, we need to do this because the OWASP SAMM says this is one of the business functions and our maturity is at a 1, we want a maturity of 3. We can also say, oh, and by the way, look at how many, actually several dozen old JavaScript libraries we have that have known vulnerabilities in them. Maybe we should fix that. So a lot of different ways to approach this problem. And I think that leads us to another article just talking about and kind of closing the loop, if you will, from our last segment about what is DevSecOps and how to enable it for your SDLC. Now, with this particular article, I sort of skipped over the what is DevSecOps because I don't know that that's something that we really need to beat the dead horse on or continue to overly define. But in terms of talking about phases, I did like the approach that this article took in breaking down the local development, software composition analysis, CI/CD, or CI, then the CD, and then your infrastructure. So I think it actually said security at each of these phases, or talked about security at each of these phases, rather than saying security is just a thing you do at one point in time, and then the rest of the time you're always doing development and always doing ops. So that was one of the things that appealed to me about this particular article.
Yeah, I think in general it's a good overview. There's a couple areas I kind of went, okay, I could debate that. But I think he points out a couple interesting things. Secrets manager, I mean, this is one of the areas that Paul and I have spent a lot of time as we've been re-architecting our software is, if you're really going to protect credentials, you really need a secrets manager or vault somewhere. And a lot of us don't think about that early enough in the process. And now we're doing crazy stuff like storing it in environment variables and some other crazy stuff. Mm-hmm. So I think that's a really interesting piece he brings in here. When you get to the infrastructure as kind of a phase 5, I think it's almost a little late in the stages. It's not that easy to put an IDS or an IPS in the infrastructure. He talks about OSSec and Wazoo, but it's more complex than that. And I think one of the things we sometimes get in trouble with is thinking about the infrastructure and the Terraform or the CloudFormation template way after the fact, and this stuff is already running in production. You're trying to figure out how to solve it then. I'd like to see some of that a little earlier in the pipeline because I think that's where a big gap is in some of these environments. So that's where I have a little bit of I'd do that a little earlier in his phases.
Mm-hmm. That's interesting. I like that perspective too, because I wonder how much of that comes at sort of that idea of lift and shift. Let's just replicate the data center into the cloud, and we'll take advantage of some of the cloud features, as opposed to what you were describing as we actually have a cloud with serverless functions that has like KMS and IAM and all these fancy good features. Maybe let's figure out what our Terraform should look like for deploying a service, and that actually would come much early on in these phases, rather than as an afterthought to say, cool, all these different teams put together these containers, now let's just throw them out there and let them talk to each other. So yeah, you've definitely brought me around to that idea, Matt.
I think also, at least to me, what was sort of neat about this article was not so much the phases 1 to 5, but the last few paragraphs after that. It's a pretty short article, at devops.com. They're usually easily consumable. But then actually talking about some of the gotchas and the what really was a bit of a shocker act to me, he had a tools and processes section, and there was no links out to other places, right? So he's actually just talking about those at a high level, which I thought was really cool, instead of sending people off either to vendors or to open source projects. So yeah, neat read.
Yeah, there's a lot of potential links off of some of these.
Yeah.
Yeah, I think there's a good thing too, because I like what are the challenges to enabling DevSecOps? It talks about enabling too many tools. And I think I of course, will be the first one to extol the virtues of lazy engineering, in the sense of we've done something twice, let's automate it. And this has been a bash script automation. Let's turn it into something more robust with better checking. And that's a good way to do so. But we've talked, not just with Doug, but a lot of other people, about about the people aspect, and that just deploying tools are only going to get you so far, because those tools aren't going to give you a deep dive into the reasoning through the protocol analysis of Bluetooth LE, or they're not going to give you insight into the workflow and the business logic of your web application that's going to prevent you might be able to throw on some rate limiting and protect yourself from brute forcing and credential stuffing. But if you have a logic flaw where you, for example, are enabling people to choose an arbitrary email address to which they can send a password reset link, no tooling is going to find that. You need some good reasoning and threat modeling to think about, why this is probably a bad idea to let anybody send a password reset link to any email, or let that email address just be easily manipulated. So I think those are some of the things I always like to highlight and throw out there as a reminder that we need more than just tools for DevSecOps.
Yes, we do. Need some people. We need a process. Then tools can fill in some nice gaps for us, add some automation, help us be a little better producing secure code, but it's not just a tools only discussion anymore. No way.
Not just a tools only. And I guess since you mentioned Matt, what you and Paul have been going through with our own site here, I can add this later, but AWS had a great article within the last week about how to use KMS and IAM to basically handling encrypted data in S3. So it's pretty AWS specific, but it's a good way of, when we're talking about architecture and designing an application, what are the different ways you're going to encrypt data and how are you protecting those keys? And I'll also use that idea of how are the keys being protected as another tie-in and callback to our ARM trusted execution environment. Because if you also have a enclave that you can drop a key into and protect to a high degree of confidence, and use that key for end-to-end encryption when communicating with another device, maybe the security of the Bluetooth encryption layer isn't as consequential, or there are other compensating controls you could have on there. So I think possibly some good threat modeling ideas that could start to architect our way through or try to solve. Yes. But with that, go ahead.
I just was saying yes.
Yes. You don't want to sit down and do some hardware architecture for the rest of the day?
Not anymore, no.
We're in the depths of trying to read that Amazon article. Like most of them that they do, they're, we just went from me talking about DevOps.com being, nice little sound bites, or not sound bites, but little morsels that we can easily consume, to the Amazon blogs are usually the exact opposite. So, lots of good stuff in there, but it just takes a while to get through that.
Takes a while to get through. Yeah.
What's interesting about the Amazon stuff, article or no, is while it's sort of cool the way they've done it, and if you get the balance right and sort of drink that Kool-Aid, especially with IAM, if you give that to like an EC2 instance, you have suddenly all your key management stuff, or a lot of your key management stuff just sort of gets taken care of automatically. But at the same time, then if you don't have those permissions right on that and someone else manages to get in there, you're giving them a smorgasbord of access. So it's a lot of power, but not just responsibility. You got to sort of tune and tweak it right.
That's right. I guess you could say don't give up root, and make sure you check your configuration that you've made it secure.
2 for 2, Mike.
2 for 2. So on that note, I think we need to leave. We'll leave those nice long articles for everyone's for homework for the week. And I want to thank you for joining us, because we'll see you next week on Application Security Weekly.